I'm Anders Hejlsberg. I thought I'd just jump in here and do a little talk on co- and contravariance in C# 4.0 since it nicely takes about 15 minutes. It's one of those funny little corners of the CLR that, interestingly, the CLR has actually supported co- and contravariance ever since generics were first put in. But they haven't really surfaced much other than in ILASM and in IFOL, which I believe was actually why they were added, or one of the motivators originally. And we have finally decided to sort of allow people to actually use them. Just to recap here, a little quick tutorial on co- and contravariance. This is some code I might write today on the existing CLR. Say I have myself an array of strings, and I have a method that can process in a string array, and I have a method that can process object arrays. And because arrays in .NET are covariant, I am permitted to pass my string array to the method that takes an object array. But interestingly, arrays are not safely covariant in .NET. Let's say my process method here does the following. In element sub 0, it stuffs the string hello, and that's all dandy. But in element sub 1, it news up a button and puts it there, and boom, things go wrong. And this is because we have defeated safety, and I'll talk about why it's not safe, or sort of the underlying reasons. But observe that because arrays are not safely covariant in .NET, whenever you have an array of a reference type, every store into an element of an array of a reference type is actually dynamically guarded by a type check. And the jitter will generate code to do that type check automatically. There are some cases where it knows not to do it, like if you're dealing with seal classes or value types or whatever, but in general, you do pay this overhead all the time, and that, of course, is unfortunate. And had we had generics from the beginning, we would have surely designed a different system, but that's all done. We can't redo that. Now let's try and look at this code written with generics instead. Let's say I have myself a list of strings, and I call this method called process of strings, and process takes an IEnumerable of object just to be maximally applicable here. That today would cause a compile time error because strings does not implement IEnumerable of object, it implements IEnumerable of string. And since today generics have been invariant, we would get a compile time error here, much to the chagrin of everybody. And they go, why can't I do that? What's unsafe about this? And indeed, this would be safe. And we now, in C# 4.0, do support safe co- and contravariance. And I'll talk about what it means for co- and contravariance to be safe. But observe here sort of that since IEnumerable of t, you can sort of intuitively at least look at this and go, why can't I do this, right? Since IEnumerable of t is read-only, it is actually safely covariant. The only thing you can do with IEnumerable is take things out of the list. And surely, if you have a list of strings, then it is safe to take them out as objects, right? But conversely, it would not be safe to put objects in. And so look at now how we sort of put co- and contravariance into the language. Here is IEnumerable t and IEnumerator of t, sort of two of the workhorses in the .NET framework. And until now, they have been invariant. But in .NET 4.0, we support co- and contravariance annotations on interfaces and delegate types. And so the way they're declared in .NET 4.0 is actually with a little out modifier on the type parameter. And this out modifier restricts t to only occur in output positions in the declaration of the interface. So when a type parameter is marked with out, it can only occur in results positions or output positions, so to speak, in an interface. In this particular case here, it's in this constructed type I-numerator of T, and it's as a T in I-numerator. Now, because T is restricted to output positions, it now becomes safe to write code. Yeah? Where's it?
That restriction to output positions, is that a compiler restriction or is that a CLR restriction?
It is both. Yes. So we mark it in metadata with a bit that says covariant, and the verifier will verify, and the compiler will also check. And because T is restricted to output positions only, we know that we can safely treat type arguments in this position as being less derived. So an I-numerable of string can now safely be treated as an I-numerable of object. And that gives us covariance. That gives us safe covariance because there's no place here where something could go wrong from a typing perspective. Now, one thing that people have asked about is, well, why couldn't you just infer that? Since in I-numerable of T and I-numerator of T, T is only used in output positions, couldn't you have just inferred that I-numerable is covariant and not made me say so by putting an out modifier on the type parameter? And yes, we could have, but it would have been one of those sort of hidden things that you may have not intended for this to be covariant, and all of a sudden you try to go at something that uses T in an input position, and you start breaking code over there because it's no longer covariant. So we thought it's important to specify it up front. Now, the converse of covariance is contravariance, and here's an example of a contravariant interface, or safely contravariant interface. Take iCompare of T, which has one method that takes two T. So in this interface, T's only occur in input positions. And we can make this contravariant now by putting an in modifier on the type parameter, which restricts T to only occur in input positions in declarations of members in that interface. And because they only occur in input positions, we can now do sort of the opposite. We can treat type arguments in that position as being more derived and safely do so. So let's say, for example, we have a thing that can compare objects. Well, it would be perfectly safe to store that as a thing that compares strings because strings are objects, right? But again, it would have not been safe if this thing were to return elements because it might return things that aren't strings. So that's sort of, in a nutshell, what contravariance looks like in C# 4.0. Just some bullet points about the actual restrictions and behaviors of contravariance. It's supported for interface and delegate types only, so not for classes in particular. And there are some reasons. I mean, it's not that it couldn't be done, but it gets very complicated because if you think about state and instance variables, which is one of the big differences between classes and interfaces, well, state is not safely co- or contravariant because a field has both an input and an output side. You can read it and you can write it, and therefore any instance data is invariant in this system. And so, yes, we could allow for classes, but you wouldn't be permitted to declare fields then, and that's not particularly useful then, is it? It is. I think the technical term here is statically checked definition site variance. There are other systems that have co-on contravariance, like use site co-on contravariance, as in Java with wildcards. Value types are always invariant, and this has been true of arrays ever since the beginning of .NET. You can't treat an int array as an object array, and neither can you treat an INumerable of int as an INumerable of object. And then finally, ref and out parameters require an invariant type, again, because they have, strictly speaking, out parameters don't have an inside, but the way they're implemented in the CLR are just as ref parameters with a bit on them. So, and since ref is bidirectional, they have to be invariant.
So what this seems to cry out for is multi-value return.
Well, it does. Why is that?
So that then you can have...
I see what you're saying. Yeah. Or, well, either that or lifting the restriction parameters. But yes, I would agree. Like, it would be nice to have tuples and multiple. Yes. But that's a discussion for a different day. Yeah, Weston.
With arrays, the CLR does support some type of variance for integral data type. So you can have the signed and unsigned version of an integer, and you can also even use enum types in arrays and interchange.
Right. Yes, but not implicitly. Those are explicit casts.
Right. So it seems like you could be able to have that sort of same variance.
You could, and I'm not sure how desirable it is, honestly. I think it's a bit of an aberration in the CLR that you can cast an int array to a uint array. I mean, strictly speaking, there's nothing unsafe. It's not like the world's going to blow up if you do it, but that
would be extensible to generic types as well. You could actually safely treat all those three types the same.
Right. Well, yeah. Well, you probably could. You probably could, but I just don't know how useful that really is. I mean, I think it's just, it's just one of those strange holes in our type system that I wish wasn't there. But yeah.
Okay.
Can the in and out keyword, can they be inferred from just looking at the interface?
Can they be what, sorry?
Can they be inferred?
Can they be inverted?
Inferred.
Oh, inferred. Yes, they could be inferred.
And C#, but C# won't infer.
Well, we chose not to infer them, but other languages certainly could. There are pros and cons, like I was alluding to earlier. An inference scheme is nice in that it's more terse and you don't have to say it and we just sort of figure it out. On the other hand, it sort of becomes a hidden contract. What if you are not done with the interface yet, but so far you have only written things that are contravariant or covariant? That would allow use of the interface, to have covariant characteristics, and then all of a sudden you go and add something and you start breaking code over there that you kind of go, why did that break? And so saying it explicitly seems to be desirable for, at least that's what we felt. Phil?
You mentioned that's restricted to interface and delegate types.
Right.
That's something you're stuck with from the CLR design. But was there a reason for the restrictions on the CLR design?
Yeah, I think they're fairly benign reasons. I think this was what Don and Andrew had time to do. And so that's what they did. And like I was saying, with classes, it's a lot trickier, right? Because the key thing that separates classes from interfaces is the ability to declare state. But the kind of state you would be able to declare is only invariant, and so the only kinds of classes that could be safely co- and contravariant are those without state. And those are just not so interesting, and so, or they might as well be interfaces. And so you sort of fall into that hole, kind of, naturally. Yeah.
So is adding in and out strictly non-breaking change?
I'm sure you could construct something that would break as a result of it, but we have added them now, and they weren't there before, and we don't believe we're going to break anything. And certainly we haven't broken anything that we've found yet. But I mean, technically speaking, someone might, through reflection, be looking at it and notice that this bit all of a sudden is set and blow up as a result of it. But yeah.
The limitation to interface and delegate types, is that compiler or CLR?
It's both. It's enforced by the compiler and by the CLR. Yeah, by the verifier.
Keep taking questions as we switch. So
Okay, Emmanuel.
So how many changes did you make in the MS Core Lib?
Oh, actually, you know what? I had one more slide, and I don't know what happened to it. Oh, there it is. Should have shown that. These are sort of the ones that matter, that we changed. And as you can see, I mean, it's IEnumerable is the one, and IQueryable, it's expression tree variant, and then the comparers, and then all of these delegates that I wish we didn't have. It'd be nice to just have one, but that's, yeah. All righty. Well, there it is. Thank you.